Yeah, got to do this video again because it didn't upload. So, all right, so I got a request to do some right triangle trig, writing equations and solving those equations. So let me clean the board up a little bit. All right, and this is all about understanding how to set up a problem and understanding the commands. All right, so let's say I give you the following. I'm going to give you rapid fire 6 here. Let me get a full screen so that it's easier for these old eyes to see what I'm doing. Yeah, I think that's going to capture everything pretty well. All right, so I'm going to do 6 problems, just like everything else. You pause the video, try it, and then follow me. See if you get it. All right, so the first one, try to find the angle A. That's what we're going to try to find. I'm going to tell you that A is 7 and B is 5. All right, you got to be able to draw these in standard position. Standard position, 7 to 5 might look something like that. It's more than 45 degrees. I know that. Is that altitude is bigger than the width? And I'm looking here and I'm going, well, what am I seeing? I'm seeing a ratio. Well, that's 2 sides of the triangle, and there are 6 names for the ratios in a triangle. I hope you know which one that is. So that one, I'll write out the equation first. The tangent of angle A is opposite over adjacent. Therefore, A is the inverse tan of 7/5. That goes in your calculator, and it'll tell you, kick back something like 53.289 degrees or something. I don't know what it is. You go put it in Google and find out. All right. So it'd been nice if you could have gone right to that last line of work just from the original picture. So again, what do you need to know how to do? Set up the picture, and you got to have, you got to know what sine, cosine, and tangent are, what 2 sides you're comparing. All right, so what's another one? Let's say I give you B is 41 degrees. I'm giving you an angle. Use it. A is 9. C refers to the hypotenuse. Let's say we don't know what it is and we want to find out. Well, you draw the picture. This is angle B. It's 41 degrees. That looks to me to be about 41 degrees. And A is 9. Well, this is a little b. I don't need to write it to answer this question. I've been given A. Well, that's A because that's not opposite. Well, little a is opposite 41 degrees. Let me write that a little bit better. There's your angle. And we're trying to find C. Well, what ratio are you looking at? Adjacent to hypotenuse. 9 to C. That's equal to what? The cosine ratio. And I've been given an angle. That's the language that asks you, cosine means, hey, the adjacent over hypotenuse. That means cosine. And it's this, 9 to C, adjacent over hypotenuse. So how do we do it? Let's go back to cosine. 2 inverse operations. Let's see, is it quicker to, yeah, it might be quicker to think of this as over 1, take the reciprocal of both sides, might be nicer for you. As an alternate way of thinking about it, equals C over 9. And then what are we going to do? I'm going to use the eraser here, just my finger. Division by 9 becomes multiplication by 9. And what is that? I don't know. Cosine, it's going to be less than root 2 over 2. The cosine of 45 is 0.71-ish. So cosine of 41 is a smaller width. So it might be something like divided by 0.67. I don't know. Well, but that gives you a sense of that length. Okay. And but go to the calculator on those. But your answer is, for me, right here, C is 9 divided by the cosine of 41. That's 2 down, 4 to go. I hope this uploads this time. If it doesn't, you're not going to see any of this, and I'm not doing it again today. Do I have time? 4 o'clock. Yes, I do. All right, so now I'm going to give you 129 degrees. I'm not going to draw the y-axis. I'm just going to do 129 degrees, which means that the reference angle is 130 to 80, 51. So 51 degree reference angle, but we're going to use that angle. Okay, so we're in the second quadrant, and I've got an x value that I'm looking for, and I'm going to tell you the hypotenuse is 12, and yes, we have a right triangle. So what do we have? Well, we got an angle. So I got to use language that uses that angle, and I got to know whether it's the sine, the cosine, or the tangent that I'm looking at. Again, I'm looking at the cosine. So the cosine of 129 degrees is equal to x over 12. That's the adjacent side, and that's the hypotenuse. All right, so it's 12 times the cosine of 129 degrees. All right, so that's what this distance is. It's 12 times the cosine of 129 degrees. You know anything that's close to 129? Maybe 120. The cosine of 120 is minus 1/2. So remember, this is an XY axis now, right? And I'm heading negative ones over here, positive ones over there. And so minus half of 12 is somewhere around minus 6-ish. So this coordinate would be minus 6-ish. Oh, I didn't find the y value. I could. And if I found that y value, then we are creating a trigonometric graphing system, coordinate system. All right. So that's how you do that one. And what if I give you a 27-degree angle, which is the first quadrant? That last problem was heading you towards vectors, by the way. 27 degrees, we have y, we have 15. We're pausing the video, giving it a go. I'm seeing the sine ratio. 27 degrees, and that's equal to y over 15. So it looks like this y value is equal to 15 times the sine of 27 degrees. 27 degrees, near anything, you know? Oh yeah, 30 degrees. Sine of 30 is a half. This is around 7.5 units. That's about 7.5 units, a rough estimate. It's gonna be a little less than that because 27 degrees is lower than 30, yes? 30 is a little bit more than 27. So you get a good estimate. Throw it in the calculator and you got it, and that's another vector. It's got magnitude and it's got direction. You're gonna study that in science, I'm sure. All right, so what do we got? Got an 83-degree angle. And I'm giving you find D, and that's 15. You see a relationship there? Ah, got an angle. I definitely either want the sine of 83 degrees, cosine of 83. We haven't been working with secant and cotangent or tangent of 83 degrees. Which one do you think it is if you're struggling to still learn this? Sure looks like opposite hypotenuse. And if you haven't learned that by now, better late than never. Gradebook's always open. You got to learn it before you leave my class. All right, so sine of 83 degrees is equal to 15 over D. I'm going to do the reciprocal. D over 15 equals 1 over the sine of 83 degrees. I like doing that. I don't know why. So all I got to do is multiply by 15, and I've isolated D. Sine of 83 is near 1. Sine of 90 is 1, right? Sine of 90 degrees is 1. 83 might be there. Not much difference in the y's. If I put that in the calculator, I'm going to guess 0.97. I might go throw it in the calculator, see how close I am. 0.97 into 15 means it's a little bit more than 15, right? If you divide a number by something less than 1, it goes in more than 15 times because it's smaller than 1. And the hypotenuse should be bigger than that. So hopefully that makes some science sense. All right, one last one. All right, I hope this uploads. This is the second time I've done the same problem. All right, so we got angle A. Try to find angle A. I'll put it here because it's a very acute angle. Oh, let's do 3 to 9. I wonder if you can write angle A in one line of work. I'm going to do it in one line of work. Tangent inverse of that ratio gives me that angle. Throw it in the calculator. Done. I'm done. Been done a long time ago today. Bye-bye. Hope this works.